Hi everyone, I'm just going to create a short video on how to construct a triangle and create a mid-segment, and then look at the relationship between the mid-segment DE compared to the base of the triangle. Okay, so first thing we're going to do is open up Geometry Sketchpad, draw a triangle, so I can just choose the point. I usually use the point tool, draw 3 points, any 3 points. And we'll go to construct and segments. So we get a nice triangle here. Just deselect that. We can click on these two sides, and we're going to find the midpoint. If you want to do each one individually, we could just go up to construct a midpoint, but I can do both at the same time. So construct midpoints. So there they are. And now I'd like to join those together. So I'm just going to go to construct once again and segment. Okay. So what we want to do is we want to compare this length here to the base. Okay, so obviously the one on the base looks longer, but maybe somebody might say it looks, twice as long or 3 times as long. So we're going to actually see what that is. So we can select this one if you want, or we can just, maybe I'll just do each one separately. So this one's already selected, so we can go measure length. And AB is 4.54. So I could actually put that right in the diagram. And click the bottom 2 points, and again we're going to measure that distance, and we get 9.08. Okay, so maybe kind of tough to see that. Yeah, it does look like it's double, but maybe if we can change the size of this slightly. Get back to 5. There we go, and we see that is actually indeed double. And again, if you want, you can choose a different vertex here. Say this one here. Maybe go to 12. 6.01, 12.01. So sometimes with the rounding, it might not be perfectly double just because of rounding errors. But it basically, if we could get it to 6, it should be 12 on the nose here. Okay. But anyways, if you want to stop any place, 6.65 times 2 would have been 13.3. Okay. Other thing that looks like is true here is AB and CD have the same slope. So let's go ahead and check that out as well. So I can do that. I'll do both of these at the same time. So I'll go AB and CD, and I'm going to go measure slopes. Now these should be pretty close to 0 because they're pretty flat. Yeah, sure enough, yeah, 0.01 and 0.01. Now if I drag C, notice the numbers are all changing, but the slopes obviously are staying the same. And you notice 7.35 times 2 is 14.70. So that's what we were looking at in this exercise. So let me just flip back to our notes. So what we noticed was this mid-segment here compared to AB along the bottom was exactly, DE was half of AB. Okay. Notice anytime you have these blue rectangle boxes, it says highlight it to see what your answer was. So let's see what they're saying the solution was. So the line segment joining the midpoints, which is our mid-segment of the 2 sides of a triangle, is half the length of the 3rd side. Okay. And it should go on to mention about the being parallel as well. Okay. Okay. The other little exercise, maybe I'll continue here, is the quadrilaterals. Okay, this one's actually really, really neat. So let me go back to my Geometry Sketchpad. Let's just maybe read here first. It says, experiment to see what results when you connect the midpoints of a variety of quadrilaterals. I did this one in my class. I should almost open, because I had a whole bunch of different quadrilaterals, and we just found the midpoint of each one. That would speed it up a little bit, but I'm just going to go ahead. We'll do a couple here. So some sort of trapezoid shape here. And let's find the midpoint. So I can just notice they're already highlighted, so I'm just going to say construct the midpoints. And I'm going to try constructing the segments. Great. Okay. Now let's see what sort of shape this thing is. Okay. It looks like some sort of diamond shape, or maybe a parallelogram, maybe a rhombus. Let's go ahead, and what I'll do is I'll just go measure their lengths. So it looks like a rhombus. Okay. Now what happens if I drag one of these vertices? Maybe another vertex. Okay, so at first glance, it looked like maybe a square because all the sides were the same length, but that's obviously not true. Okay, so, but we do notice that AD and BC are the same, as well as AB and DC are the same. Okay, so it appears to be parallelogram. Now, is it a rhombus? So what you might want to do is, is it a rectangle? So we might want to check the slopes again. So we're going to measure slopes. Oops, something must be selected here. There's my slopes, and let's measure these two slopes here as well. Okay, so definitely it's a parallelogram. Opposite sides are parallel, and they're also the same length. Okay, is it a rectangle? Remember, rectangles would have 90 degrees in here. It certainly doesn't look like 90, and I think if we drag this point out here, it'll probably exaggerate that more. Actually, see there, we're getting closer to a rectangle, but if we go like this, obviously it's not a rectangle. Plus, the other thing you would notice with the slopes are negative reciprocals, which they're not. Okay. Anytime you want to check, you can actually multiply the two slopes together, like 0.48 and negative 0.22. If it is ever equal to -1, that would tell me that that's a 90 at B, okay, or A or D or C. Okay. So kind of neat how we can drag this around. So it doesn't matter what sort of quadrilateral we started with. We notice that the slopes are the same, as well as the lengths are the same. So it will always create a parallelogram. Okay, so hopefully that helps. We're almost done the course here, so this stuff's a little trickier. So anyways, just maybe make notes on that, and because there might be a couple questions on the exam from this chapter. So anyways, good luck with the study. Talk to you later. Bye.